This is from 2018. Okay, this is from 2018. Let f and g from R to R be such that f of x is equal to x raised to k into g of x, where k is a positive integer. That means k is a natural number. Suppose g is continuous at x equal to 0, then option A, f is continuous at 0 but not differentiable at 0. F is differentiable at 0. Third, f dash of 0 is 0 for every positive integer k. F dash of 0 is g of 0 if k is 1, and f dash of 0 is 0 if k is greater than or equal to 2. Okay, this is also a multiple select question, and we know that g is continuous but not differentiable. Okay, and well, just in the previous question we have seen that for the product to be differentiable, it's not necessary that, well, one of the two, both of them should be differentiable, right? Okay, so let us go for f of x, x raised to k into g of x. Okay, now what do we want? We want to check whether it is continuous at 0. K belongs to n. Is it continuous at 0? Yes, it is, because f of 0 is 0 raised to k into g of 0, and limit of f as x tends to 0 is f of 0, right? And x raised to k and g of x, well, again, if two functions are continuous, then the product must be continuous, right? So continuity is resolved. It's continuous. Okay, you can also write it here. Also can be proved using algebra of continuous functions. Okay, that if product of two functions is given and both individual functions are continuous, then the product must be continuous. Okay, so continuous part is there, but we haven't yet commented anything on the differentiability. So let's find out. Okay, how to find it out? Let's use the first principle. Okay, limit as h tends to 0, f of 0 plus h minus f of 0 upon h. Okay, f of h is what we need. So at h it would be h raised to k into g of h minus f of 0. Yeah, f of 0 is 0, right? F of 0 is 0. Why is f of 0 0? Because k is a positive integer. Okay, k is a positive integer, so f of 0 is 0. I can write it here upon h. Okay, so what have we got there? What have we got there? Limit h tends to 0, h raised to k minus 1 into g of h. Okay, now look, I can write it as limit as h tends to 0, h raised to k minus 1 into limit as h tends to 0, g of h. Okay, now because g of h is continuous, g of x is continuous, as h tends to 0, this should tend to g of 0. Okay, this should tend to g of 0. But what about this? What about this? Okay, now here we consider two cases. If k is greater than 1, then this is equal to 0, like 0 squared, 0 raised to 1, 0 raised to 2, 0 raised to 3, they are all zeros. Okay, so that is 0. But what about k equal to 1? If k equals 1, then what will we get? Limit h tends to 0. Okay, well, we'll get something like 0 raised to 0 or h raised to 0, right? And h raised to 0 is how much? That's 1. No matter how close you go to that, h raised to 0 will always be 1. but 1 into g of 0. Okay, so in either of the cases derivative exists. And hence it is differentiable. Hence it is differentiable at x equal to 0. So option B is correct. Okay, now can option C be right? Let's think about it. F dash of 0 is 0 for every positive integer k. No. It will be equal to 0 for k greater than 1, but not k equal to 1. Every positive, say it would be true for every positive integer greater than 1. Okay, and let's come to D. F dash of 0 is equal to g of 0 if k is equal to 1. That's true. And f dash of 0 is 0 if k is greater than or equal to 2. That's true. Why? Again, we have to split that. Okay, we have got it as k minus 1 because of the cancellation of 1 power of h in the numerator by this first principle definition of derivative. And therefore, when k is greater than 1, then we'll get 0. 0 into g of 0 is 0. But if k is equal to 1, then that limit is equal to 1. And therefore, f dash of 0, okay, let me write it in blue color. And therefore, f dash of 0 is g of 0. So when k equals 1, the derivative is g of 0. But when k is greater than 1, then that is 0. But more importantly, f dash of 0 exists. So which option is true? B is true and D is true, but not C. And A is also not right because it is differential. Have you understood this? Look, in such problems, when the first principle is to be used for finding the derivatives, in most of the cases the value where you want to find the derivative will be 0, so that it becomes easier to solve the problem. ठीक है?